Hello and welcome to another mini lecture on CS200. We're going to continue some of the topics in Chapter 8, User-Defined Methods. In this one, we're going to look at some things that we can do with parameters and as well with arrays and how they're passed and updated with methods. So first of all, parameter error checking. This is Chapter 8.11. What the book is mentioning or trying to illustrate here is that when parameters are used in methods, in many cases they have bounds that make sense. So for example, with dates of the calendar month, we know that we'll never have one greater than 31, we'll never have one less than 1. So it's a good thing to check this and provide a message indicating this. So this allows us to continue with the method, see how they have using 1 and then they set it to 1. So this allows the method to continue, but there's a message that's printed out so that the user knows, or actually the tester knows, that they've encountered a mistake, but it's able to continue and go on to the next part of the method, next block. So this is kind of a nice feature. There's many instances when the use of parameter checking makes very good sense. Dates is one. For example, if you looked at zip codes in Colorado, you'd want to have ones that begin with an 8 because there aren't any zip codes that begin with a number greater than 8 in Colorado. So these kinds of things are important. Let's continue on to 8.12. And what this is not as crucial to understand because this is using a scanner and methods. Remember, a scanner is an object, so any object can be passed to a method. So one way in which this is used is, for example, in your main, you declare the scanner that's down below, and then you can actually print out the values that you obtain by scanning in the objects in the method. I'm not sure why you would want to do this because you can do all the inputs inside of main instead of inside of the method. Remember what I was talking about trying to keep each method very specific to a specific task. So in this one, not only are you doing the calculation, but you're also scanning in information from the user. Not the best idea, but this is just showing something to illustrate how it can be done. Okay, so again, remember a scanner is an object, so you can have multiple scanners to read in different inputs. However, you can get into trouble with this because scanner, normally we always call it SCNR, but that doesn't have to be the name. But here in this illustration, what they're trying to show is, well, this is actually an exercise, but you want to try to get information using the same scanner object. And notice you're inside get and count name letters, but the scanner object is actually declared inside of that. So I'll leave this exercise for you to do, and let's move on to the next section. The next section is also one that we don't need to spend a whole lot of time on, but it's called a perfect size array. So this is one, remember the example we gave earlier in last Thursday's lecture, in which we had an array of 10, and then we only used 5 of the different elements. And in your exercise that you had for your lab last week, we were asked to declare an array of 20, but in many cases we didn't use all 20 elements. A perfect size array is one in which we use all the elements. So think about, for example, days of the week. We know there's going to be 7, so we can declare an array of 7 because we know that exactly 7 and only 7 different values will be used. So it's interesting because how a perfect size array is put on the heap. Now this is worth looking at. You can see here that we have high temps because it's for a week. It's going to have 7 different days. So in memory, high temps is given as a pointer, say 242 is the index, and the different values are given. There's actually a pointer from here to tell us that the actual values are stored here. So we have not only all the elements, but they also have a length variable that's stored in memory. So this one tells us exactly where the memory goes. So it's an indirect reference to this. So what we mean by indirect is there's a pointer to 242. That's a memory location. It's not something you would know as a programmer. And then in 242, it tells us there's a pointer to space 351. So that's another index. And this is on the heap. And then we have 7 different temperatures stored here. Usually they're in contiguous memory spaces. And then at last, there is a length variable that stores the length of that. Okay. So array length, and it has that variable, and it knows exactly that there's 7. Okay. That's why it should be faster than having to count, because it's stored in that. So again, this is called a perfect size array. So when we pass these to a method, remember, an array is not a primitive object. It's actually it's almost thought of as a class. And because of that, you can see here, we've declared an array, and this array is of size 3. So what happens is, in memory, just like in the last example, we have, this is in the stack, and this is in the heap. When you get to operating systems, you'll realize that this is very volatile, so it's always changing, but this is more stable, and it's in a first in, first out different style. So a stack is different than a queue, but in our case, we're just going to put a single value onto the stack, and that's going to be the address of where our array starts, and of course we've got the length. So in the next step, we're just going to fill the array with values of 10. So we go down to this method, and this method says we're going to have 2 different values. One is the array reference, right, where the array starts, and the other is the initialization value, or init value, which we've declared in the parameter for that particular array method called fill. So then we loop through 10 times, for 3 times, because we're just going to keep looping through until we fill our array with values of 10. And we know to stop because we have the length, and we're comparing it against the length each time. So that's exactly what happens in memory. And then the index, you can see we have a variable here, and this is the index that we are keeping track of in our for loop. So when it gets called back, remember the scope is out. So you can see that these are grayed out, which means that they are not accessible anymore. Only the pointer to the array is accessible, because we're no longer inside of this block. So we can assign 2 different, you can see here, look at how this array is defined. This is different than what we saw before. Because it's a perfect size, we can supply the values. And it already knows that it's going to be an array of size 3. Same with this Tuesday temperatures. You can see it's a size 3. So instead of declaring it as 3 within the hard brackets, we can just supply the variable here inside of these braces, and this will give us the values. Okay, so this makes a perfect size array. It only declares a size 3. So adding more to it, we'd have to do some kind of append method, and how they describe it here is what they do. They have a result array, which has index plus first array length. So this is how we're appending. We're actually building a larger array, but we have to use the index and we have to offset it with the length of the first one. For example, if it's 3, this value would be 1 or 0 actually, and then this would be the length or 3, so this would have the value 3. So the index for the first array would be 0, 1, 2, and for the second array it would be 3, 4, 5. So that's exactly what we see here. This I would look at in more detail. It just shows you how to append perfect size arrays or ones that have been declared. So what we saw in the last homework assignment, the last lab, is an oversized array because it's telling you 20, so it's allocating space for 20 as opposed to just allocating space for the number of elements that we used. So what happens here is much like the last one, we're declaring an array of string. Okay. And so what's happened is the array is called shopping list and it's of size 5. So you can see here we've got the pointer down to the memory address where the array starts, and we've also got a length. So we also have declared an integer, and this is just a static integer that goes on in the stack. It's not on the heap. So what happens here is we start adding to variables. We start adding values to our array and so forth. So this is going to tell us the list size is increasing each time when we add a particular element. So, and so on and so on. We can see here that we've added another thing, oranges, and then soon we'll add apples. And each time it's adding to the list size, but you notice the list length is not changing. So we have a disparity between the shopping list size and the shopping list length. The reason for that is this is how many of the values of how many elements in the array have been assigned. This is how many are available total. So declaring for oversized arrays, you can see here we have quiz answer capacity. So remember in the past, we would declare this and we put a number in here like 20, but here we can actually supply it with a variable we want. And we can also do it with a fixed number, like instead of having quiz answer capacity here, we can just put the number 200 inside here. This is, of course, indicating that it's not changeable. It's going to be a static value. So in section 815, we can update an oversized array. I'm going to skip over this, but you can definitely go through the steps just like I did, and you can see how things are updating things. Now it's important because remember how we talked about a copy being put of the particular variable? Actually, inside of the speed, you can see here it's much like what we saw. We have the size. In the second step, we're adding an element to the list. Okay. So add me is what's being done. See, we have a string called add me, and then we have to check to see if it's got space, right? If it doesn't have space, then we can't add it any longer because we're out of space in the array, and it's going to tell us that we're doing something out of bounds. Okay. So this is something to go through, and you can see how things are done in memory. So why in a computer programming class should you worry about how things are in memory? Because when your program has some issues, it's really good to know or to visualize exactly what's going on behind the scenes or under the hood, and you can actually see or think about why you're running out of bounds in your array. Okay, so of course you can remove an element just the same way. This is another way to, for example, if you're searching and you want to have something removed, they have a variable they call target found, which is a Boolean, and they're saying it's false. But if they find it after scanning through the index, if they find it, then they say they update target found to true. I suggest you look through this code and try to understand it. Uh, if you run into any issues, we can discuss it in our next class meeting. Okay, so it's possible that we can't find a value inside of an array. In that case, it's never updated from false to true. Okay, so if we want to compare a perfect size array to one that's of fixed size or perfect size, it says array size is a parameter, right? So if it's not a parameter, we're supplying values only, right? So remember the curly braces that we had and we provided values for temperatures? That will tell us whether it's a perfect size or not. If we've already supplied those values, those 3 values, for example, in that previous code, then we're stuck with 3. But if we declare it array equal, string array size equals new, string, and then we have a value put in there like 20 or even a variable, then we can have it as an oversized array. So remember, the return value also matters because the return value can be a reference to an array or it can be an integer. Okay, so what this is saying is if the return type is an int, for example, the method can use an oversized array, but that doesn't guarantee it. So I'd look over this chart. This chart, again, the understanding of what's a perfect size and what's an oversize and how they're declared should be clear at this point. But just remember that we can do lots of things with an oversized array that we can't with a perfect.